Yes, good afternoon everyone students. We discussed regarding the drugs classification based on pharmacological effect, the pharmacological response in the last class. The last what we discussed is antimicrobial drugs. The drugs which are going to be acting against a microorganism, they are called as antimicrobial drugs. They are of three types: antibiotics, antiseptics and disinfectants. And we are having antibiotics here. The antibiotics are nothing but the metabolic derivatives which are taking from one microorganism and acting against another microorganism. They are called as antibiotics. That we already discussed two types of antibiotics based on their action: bactericidal, bacteriostatic, and we discussed about the spectrum, the range of the particular antibiotic, that is broad spectrum and narrow spectrum and limited spectrum antibiotics we discussed already. And now we are having another class of that particular antimicrobial drug, which is going to be antiseptics. What are antiseptics? What are antiseptics? Antiseptics are the chemical substances which are going to be acting against the microbial growth, but they are not going to cause any damage to your living tissues. They are not going to cause any damage to living tissues. They are called as antiseptics. They are all going to be external use only. The antibiotics are going to be internal use, whereas the antiseptics are going to be external use. The chemical substances which are going to make the microbial growth will be prevented, but it is not going to cause any damage to the living tissue. Then that particular chemical substance is called as antiseptic. I think everyone is having aware of this antiseptic. The first and best example we are having is Dettol. First and the best example we are going to have is Dettol. So what is Dettol? Usually you are using for as the antiseptic even when you are having a wound or when you are having some scratches on your skin, when you are fall down. When we are going to use this Dettol as an antiseptic. So many times what the question they are going to ask is, what is the composition of Dettol? What is the composition of Dettol? This is chloroxylenol. It is going to be chloroxylenol and terpineol. We are going to have chloroxylenol and terpineol will be the composition for terpineol, and chloroxylenol will be the composition of Dettol. So many times they are asking it. So whenever you are having any wounds or something is going to be have scratch on your skin, we are going to use Dettol is going to be applicable on that one. That is a best example for antiseptic. And bithionol or bithionol, whatever you are going to call this one, bithionol or bithionol, which is also a best antiseptic we are going to have. It is going many times asked question is, what is the antibiotic which is used in soaps? Which is going to be used in soaps? That is going to be bithionol. It's going to be bithionol. That is the one which we are going to use it in case of soaps. In case of soaps, we are going to have bithionol. Bithionol is the one which we are going to use it in the soaps preparation. The role of bithionol in the soaps, what it is? It's acting as an antibiotic. So these are what we are going to have. The antibiotic. Next one, iodine, is in terms of tincture of iodine we are going to call. Tincture of iodine. What is tincture of iodine? It is prepared by 2 to 3% I2 solution in alcohol water mixer. In alcohol water mixer, that is going to be called as tincture of iodine. what usually are going to have the iodine? Iodine is always going to be get solubility by the addition of Ki, Ki plus I2, and we are going to have spirit, that is alcohol. So this is what usually the composition we are going to have in tincture of iodine. What is going to be consisting of? It's a 2 to 3% iodine solution in alcohol water mixer. What we are going to have the composition? Iodine plus Ki plus spirit, that is alcohol, are going to be present in the given mixer, that is going to be acting as a antiseptic. Tincture of iodine, whenever you are getting the wound, immediately the doctor is going to clean that surface by using tincture of iodine, that is going to be causing the antimicrobial infection there. The microbial infection, anything is going to be happen, that is going to be get cured by this application of tincture of iodine. The next antiseptic what we are having is hydrogen peroxide, H2O2. I think everyone is knowing this one. It is sold in the name of perhydrol. Whenever you are going to have anything to be cleaned, we are immediately applying the hydrogen peroxide. We are going to get some foam on that one, so that it is going to be get cleaned. Hydrogen peroxide is going to have nascent oxygen, which is an active disinfectant we are going to have. That is what we are using, the H2O2. And one more is boric acid. We are having one more disinfectant is boric acid, which is going to be acting as an disinfectant in the case of eye lotion. This is also so many times asked one. Boric acid is an antiseptic. We are using it in eye lotion. That is eye drops when we are having. There we are going to use the antibiotic boric acid. So that is also one of the best antibiotic we are going to have. 0.2% phenol. This is very important one. 0.2% phenol is going to be acting as antiseptic, whereas 1% phenol is going to be acting as disinfectant. So always when you are going to take a thing in a more concentration, that is going to be acting as disinfectant, whereas it is taken in low concentration, it is going to be acting as antiseptic. So 0.2% phenol, we are going to have antiseptic property. And next one we are having is soframycin and furacin. Usually we are going to use antifungal infections by using these two antiseptics are applicable. That is ointment. It is going to be an ointment that is going to be applied on the surfaces wherever you are getting the wound in order to prevent the antifungal growth. That is fungal growth. So it is antifungal, but even normally the microbes all can be get cleaned by using this one. We are going to have iodoform. The next antiseptic we are having is iodoform. So iodoform is can able to liberate active iodine so that it is able to make a disinfectant, that is infection can be cured. That's why it is going to be acting as antiseptic. Okay, understand? So now all these things are going to be acting as antiseptics. Even Savlon we can able to use. So we are going to have Dettol, Bithionol, and we are going to have iodine, and then iodine is in the name of tincture of iodine, and iodoform, H2O2, and we are going to take boric acid, 0.2% phenol, and soframycin and furamycin. All these are going to be acting as antiseptics. So what are antiseptics? They are going to be prevent the growth of microorganism, and it is not going to damage the living tissue. They are called as antiseptics. They are called as antiseptics. Now these are all comes under antiseptics. Understand? So these are the things we are supposed to remember them. The best asking questions are, which of the following is used as antiseptic in the soaps? That is bithionol or bithionol. So what is the composition of Dettol? Chloroxylenol and terpineol. And that is one more. And we are going to use boric acid. What is the role of boric acid in eye wash or eye lotion? It is going to be acting as antiseptic. Or what is the antiseptic used in eye drops? That is boric acid. So these are the questions you can able to expect from your antiseptics concern. The next we will go for disinfectants. So the next one is disinfectant. What is disinfectant? The chemical substance which is going to prevent the growth of microorganism. At the same time, it is causing the damage to the living tissue. So we can't able to use these disinfectants on living tissues. Whereas antiseptics, what we said, they are not causing the damage to the living tissue. That's why we can able to use them on the surface of the skin so that we can able to prevent the microbial growth. But when they are going to take disinfectant, these are going to be affecting the living tissue also. That's why we are not able to use them on a living tissue. That's why the disinfectants are going to be the chemical substances which are not able to be used for a living tissue or which is going to damage the living tissue are called as disinfectants. So what are the examples we are having for the disinfectants? The first and best already we discussed about 0.2% phenol, and now this is going to be 1% phenol. 0.2% phenol is going to be acting as antiseptic, whereas 1% phenol is going to be acting as disinfectant. And Dettol. I said already the certain things are going to be used as both disinfectant as antiseptic. The best example we can have the Dettol. So Dettol is going to be in lesser quantity. When you are diluting it, we can able to use it for cleaning the surface of the skin also. But when it is going to be taken in a concentrated form, then we can able to use on the floor cleaning. They are all inanimate things only we can able to clean by using them. So the Dettol can be used as both disinfectant and antiseptic, and phenol also can be used as disinfectant and antiseptic. That is what, depending upon the concentration what we are going to use. The concentration what we are going to decide is going to be disinfectant or antiseptic. And we are able to use chlorine water. Chlorine can also be used 0.2 to 0.4 ppm. It is going to be 0.2 to 0.4 ppm in aqueous solution. We are going to use the chlorine water is going to be consisting of OCl, that is hypochlorite, which is going to be using as a disinfectant, and even many cases we can use this one. I think all the water when we are going to supply domestically, they are supposed to be added with chlorine water. That chlorine water should be having the limit 0.2 to 0.4 ppm. If it is exceeding, it is going to be harm for us. That's why always it is supposed to be 0.2 to 0.4 ppm in water is going to be acting as an antiseptic. The chlorine water is also going to be acting as antiseptic. Formalin. What is formalin? It is going to be 40% formaldehyde is going to be called as formalin. So that formalin is going to be acting as biological specimen preservative. It is going to be acting as biological specimen preservative. Whenever you can able to see in your bio laboratories, what we can able to find, there we can able to find the specimens like animals we can able to preserve, or plants are going to be preserved in a bottle. If you can observe what that bottle is going to be consisting of, it's a formalin solution. That is going to be 40% aqueous formaldehyde is called as formalin solution. So that formalin can be used for preserving the biological specimen, as this formalin is going to be preventing the microbial infection on those tissues. That is why we are using the formalin. And the formaldehyde in low concentration can be used as a disinfectant. So these are the common questions what we are going to have here is, what will be the difference between 0.2% phenol and 1% phenol? What the difference it is? 0.2% phenol is going to be acting as antiseptic, 1% phenol is going to be acting as disinfectant. And we are able to get the question like, which of the following is used as both disinfectant and antiseptic? That we can able to take Dettol, and even phenol, it is in concentration variability. And the chlorine water, formalin are going to be acting as disinfectants, these are all comes under antimicrobial drugs. These are all comes under antimicrobial drugs. So the next class of drugs we are having is anti-fertility drugs. We are going to have the next class is anti-fertility. What do you mean by fertility? When we are going to have fertilization. I think everyone is going to have male gamete and female gamete, and they combined, they are going to produce a offspring that is going to be called as fertilization. They are going to develop zygote. Now, when we are going to take anti-fertility drugs, the anti-fertility drugs are the drugs which are going to be used against fertilization. When we want to prevent the pregnancy, then we can able to use these anti-fertility drugs. So what is a natural anti-fertile drug we are having inside? It is progesterone. We are going to have progesterone is the best anti-fertile hormone we are having inside. When this hormone is going to be secreted, it is going to prevent the pregnancy. So that's why it is going to be a natural anti-fertile. So the same thing we can able to use whenever we are going to have the preparation of drug. Always we are going to use synthetic progesterones. Synthetic progesterones are going to be having the anti-fertility effect, so that all anti-fertility drugs are maximum comes under synthetic progesterone. We are having the examples here: norethindrone, novestrol, ethinyl estradiol is called as novestrol, and this is going to be norethindrone. We can able to use alone for the prevention of fertility, or we can able to use both together for this one. And when you are going to take progesterone and synthetic progesterone, it's a synthetic progesterone. Norethindrone is a synthetic progesterone. You are going to have the synthetic progesterones are going to be more effective compared to the progesterone, and along with novestrol we are going to use it for the anti-fertility purpose. We are going to have the other anti-fertile drugs we are going to use is mifepristone. It is also called as morning pill. We are going to have oral contraceptives we are going to be. So this is the best example we are having, mifepristone, that is going to be anti-fertile drug which is going to be taken oral, and oral pills they are going to be, and morning pill they are going to be set. So what is the role of these anti-fertility drugs? They are all going to prevent the fertilization. How they are going to prevent the fertilization? So they are going to make the mucus is going to be get developed more, so that the semen is not going to be get more sperm motility is not going to be more. If the sperm is not motile, they can't able to reach ovary, so that they can't able to get fertilized. So that is the way the fertilization can be controlled by these drugs. They are called as the synthetic progesterones mainly. Norethindrone is one example, and novestrol is another example, and we are going to have one more. It is mifepristone. The mifepristone is also called as morning pill, that is going to be used for preventing the fertilization. So this is for control of birth control. Birth control can be done by using these anti-fertility drugs. So the one we are having the population to be controlled, at that time they are going to be used these conditions. Oral contraceptives, they are going to be one of the class of anti-fertility drugs we are going to have. Understand? So this is about your drugs, which are going to be having a very vital role in making us to get not infected by any microorganism, and to maintain our digestive system properly by taking antacids and all. And inflammation can be prevented by antihistamines. And we have studied anti-fertility drugs and antimicrobial drugs, and we are having anti pain, that is painkillers, analgesics we discussed, and neurologically active drugs like antidepressants, antihypertension, and hypnotics we discussed. All these drugs are going to be playing a vital role in our life, so that it is supposed to be studied in detail to understand how they are going to be acting on. So that's what it is about the drugs. Now we are going to have the next. It is important in our life is, what is important in our life? The chemistry in everyday life, the food. The next one we are going to have food. How this food is going to be get quality by using your chemistry. That is what we are going to study now. Next one is food. So the next one we are having is chemicals in food. So the food, what we are going to add the chemicals. So the normally food is going to be consisting of the ingredient like carbohydrates, vitamins, minerals, and we are going to have proteins and the lipids. All these are commonly we are going to have in food. But if you want to improve the food, then we are going to add some additives for that particular food, that obviously they are chemicals only. So how we are going to make the food to get quality? How we are going to make the quality of the food more? So for that purpose, first of all we are supposed to add food preservatives. We are supposed to make the preservation for the longer time. So that is food preservatives we are going to add, and we can able to make antioxidants for certain things. It is also one of the food preservative only. We are going to make it get antioxidant, and we are going to have artificial sweeteners. Artificial sweeteners we are going to make. We are having enrichers. Or we can have flavor improvers. We are going to have flavor improvers. Like this, if you are keep on adding so many food additives you can able to get, but out of them we are going to discuss in detail about these three: food preservatives, antioxidants, and artificial sweeteners. These three are only we are going to discuss. So what will be the food preservative is going to be? What are food preservative? They are going to be preserving the food. Actually, certain foods are not available. I think earlier days, if you are able to remember, all the foods are not going to be available throughout the year. There are certain foods, they are going to be seasonal. The seasonal foods are going to be available in that particular season only. Say for example, mango. That mango is going to be seasonal food which is going to be available in the summer. We can't able to see them in winter, so it is going to be available in summer season. Like that we are going to have certain foods are going to be seasonal, they will be available during that time only. But a man can able to do, that is throughout the year they can able to make it by making them preserve. So the preservative is going to be added for your mango as a pickle. I think the pickle is going to be one of the preserved food of your mango. So that is nothing but how we are going to make that preservation. We can use table salt. We are adding salt for that one. So that is nothing but sodium chloride, and we are going to add oil. We are going to add oil. So oil, table salt, sugar, they are all comes under preservatives which are natural. They are always natural preservatives there. Table salt is going to be added. That is going to be preserving your food for a longer time. And oil and sugar. These are all going to be mixed up with your pickle so that it is going to be making them to last for a longer time. That is how I can able to preserve my food by using table salt, oil and sugar. And which is a chemical we are going to have sodium benzoate. sodium benzoate C6H5COONA, which is going to be acting as a chemical that is going to preserve so many foods. For so many foods they are going to add sodium benzoate. So what is the advantage of sodium benzoate? The sodium benzoate is not going to make any harm to your body. The sodium benzoate can be chemically modified to hippuric acid, can be excreted easily, so that we can able to use benzoic acid as a common food preservative for so many things. And even salts of sorbic acid and propionic acid. Salts of sorbic acid and propionic acid are going to be a good preservatives for us in preserving the food. So all these food preservatives are maintaining the life of that food for a longer time. That is what the use of these food preservatives. So that is what we are going to discuss in the food preservative, that is table salt, oil, sugar, sodium benzoate, salts of sorbic acid and propionic acid are going to prevent the microbial growth on your particular food substance. Generally the foods are going to be affected easily by the microorganism. These microorganisms growth will be prevented by using any of these, so that the food will not be get spoiled. The spoiling of food is obviously because of microbes only. The microbes are growing on the particular food and they are going to make the damage or spoiling of the food. That spoiling of the food is going to be prevented by preventing the growth of microorganism. That preventing of growth of microorganism can be done by any of them. Is it clear? Yes. The next one, antioxidant. Next one is antioxidant. What are antioxidants? These are going to be called as sacrificial oxidizing agents. They are going to be sacrificial oxidants. What it means? Say for example, if any food is going to be get spoiled by oxidation, now we are going to add these antioxidants so that they can able to prevent the oxidation by they will undergo oxidation. That is, instead of food is getting oxidized, your antioxidant which you have added will be get oxidized before. So they are called as sacrificial oxidants. That means the oxidation of the food can be get prevented by adding these antioxidants. These antioxidants will be oxidized before the food is getting oxidized. That is what they are called as sacrificial antioxidants. The best example we are having is BHA, BHT. Butyrated hydroxyanisole. Butyrated hydroxyanisole. This is one, butyrated hydroxytoluene. Butylated hydroxytoluene. These are the two antioxidants which are going to be used for preventing the oxidation, which are going to be get oxidized easily. The fats and edible oils what you are having, they are the one which is going to be get oxidized by the oxygen which is present in your air. So we are going to make any oil is kept in air for longer time, it is going to get a smell. It's called as rancid smell, and that is called rancidity. Why they are becoming rancid? It is because of the oxidation of oil which is going to be present. It is making that oil to get rancid. It is get spoiled. That oxygen interaction with your oils can be prevented by adding BHA or BHT. So they will be protecting their oil before the oil is getting oxidized. They will be get oxidized. That's why the oil will not be get oxidized. That is what you can have. BHA, BHT, butyrated hydroxyanisole, butylated hydroxytoluene are the two best antioxidants which is going to be used for your ghee or your oil or fats what we are having to prevent oxidation. And one more natural antioxidant we are having is vitamin E. The vitamin E is the best antioxidant which is going to be used for the maximum cosmetics. Whenever you are using cosmetics, they are going to be make vitamin E added, so that it is going to be causing antioxidant for that one. Even it is going to be added for so many purposes for preventing the oxidation. And the best one we are having sulfur dioxide and sulfites. Sulfur dioxide and sulfites are going to be added to your wine or beer. The wines and beer is going to be get added up with your sulfur dioxide or sulfite. They can be better antioxidants which are going to be preventing the oxidation of your wine or beer. So when they are going to be oxidized, they will be get sour in taste. That's why that is not supposed to be happen. So they are going to add up SO2 and sulfite. They are going to be acting as a antioxidants for your wine and beer. Understand? And natural sugar syrup, they are going to be used, already we said. And you can use the cut and peeled vegetables or fruits are going to be prevented the oxidation by using sugar syrup. In sugar syrup they are going to be get, so that they will be get preventing the oxidation of those things, so that they will be preserved for a longer time. So that is about your antioxidants we are having. Next we will see the artificial sweeteners. So next one, artificial sweeteners. What are artificial sweeteners? Generally we are going to get taste for any food by adding the sugar, which is commonly used one is sucrose. So that sucrose what we are going to add to the food, that is going to be making it sweeter and tastier, so that we can have a good taste on our tongue. That is what we are going to be sweetening. But what we are going to call them here? Artificial sweeteners. What are artificial sweeteners? They are going to be sweetening your food, but they are not going to add any calorific value for your food. So what sucrose is going to do? Sucrose will be metabolized in your body and it is going to be get converted to glucose and fructose, so that it can able to increase the calorific value of your food. For a person who is suffering with diabetes mellitus or who is suffering from coronary diseases, they are not supposed to take excess calories in your food. That's why they can't able to take that sucrose, which is even though tastier, it is also causing some damage to your metabolism. That's why it is not supposed to be used. For that purpose, we are given a solution in the form of artificial sweeteners. These artificial sweeteners are going to add the sweetness to your food, but they are going to not add any calorific values for your body, and even they are not biodegradable in a human body. They will be excreted, so that we can able not get any extra metabolites from the artificial sweetness what we are going to add. And the first artificial sweetener is discovered is Saccharine. This is 550 times sweeter. This is going to be 550 times sweeter than your normal sucrose what you are taking. So it is going to be a good alternative for your sucrose. So that is going to be present as a non-metabolite. That is, it is not going to be degraded. So that it is a alternative for your sucrose, which is going to be used for your food or sweets what you are going to make. And the next one we are having is aspartame. This is 100 times sweeter. This is 100 times sweeter than your sucrose, and this aspartame is going to be have one amide bond which is made from the two amino acids, phenylalanine and aspartic acid. Phenylalanine and aspartic acid are going to be get joined, so that we are going to get aspartame. It is going to be 100 times sweeter. But what disadvantage you are having with this one? Not stable. It's not stable at cooking temperature. It's not stable at cooking temperature. As it is not stable at cooking temperature, we can't use this aspartame during a normal food additive. So that is why it is only restricted use in cool drinks only. Soft drinks we are having, they are all made of aspartame. So where we are going to have only cooling, there is no cooking temperature. It is not stable even at room temperature and cooking temperature. We can't able to use them. That's why it is restricted use for only the cool drinks what you are going to have. That is the aspartame. And next one we are going to have sucralose. Sucralose is a trichlorosucrose. We are going to add 3 chlorines to your sucrose at 3 places. That is going to be having sucralose. It is going to be 650 times sweeter. It is going to be 650 times sweeter and it is going to be stable at cooking temperature. It is also a good alternative for your sucrose and it is not biodegradable in your human body. That is the reason we can use widely this sucralose. And we are having one more called ADDITIVES. It is going to be 2000 times sweeter. It is going to be 2000 times sweeter. It's very less quantity is only going to give so much of sweetness. That's why we are not able to control the sweetness by adding the ADDITIVES. That's why it is not preferable. And aspartame is not preferable because it is not stable at cooking temperature and we can't able to use this one for a longer one. That's why it is also restricted uses in soft drinks. Saccharine and sucralose, which are going to be 550 times and 650 times sweeter than your sucrose, which are going to be widely used when we are going to take as an artificial sweetening. What is the use of this artificial sweeteners? They are good alternative for the patients of a sugar patient like diabetes mellitus patient or coronary artery disease patients. When they are going to be have these artificial sweeteners are added to their food, they are not going to increase their calorific value but giving a sweet taste to their taste buds. That's the reason we are going to use these artificial sweeteners nowadays at a very high level. And moreover, what the questions we are going to get it from this one, which of the following is much sweeter than sucrose? That is 2000 times sweeter, that is ADDITIVES. And which of the following is not able to be used at cooking temperature or a cooking food? Then it is going to be the answer, the aspartame. How many amide bonds are going to be present in aspartame? It is going to be 1 amide bond. How many chlorines are going to be present in sucrose? In case of sucralose, it is 3 chlorines. These are the questions they can able to be asked during the exam. So that's what you are supposed to remember, their names and their how many times they are sweeter. Always, otherwise they will give order of sweetness. Which is the lowest we are having? Aspartame. Aspartame is going to be more than, so lesser than saccharine. Saccharine lesser than sucralose. Sucralose lesser than ADDITIVES. These are the questions possible from this particular area, that is artificial sweeteners. And next, enrichment. So what are enrichment? Say for example, you are going to have the milk. The milk is going to be having some proteins and some lactose. Now that milk is not going to have sufficient proteins because of dilution what they are doing it, or the milk dairies what they are going to do. Now we want to make this one enriched with protein. What you are going to add? Protein X. So we are going to have certain artificial protein X we are going to have to increase the protein value of a food. Or if you want to make the calorific value of that one, we are going to have other alternatives to add the calorific values for your food. That is how we can able to enrich the nutrients for a food by adding these enrichers. Whichever enrichment you want. You want vitamin enrichment, you add vitamin. If you want protein enrichment, you can add. If you want calorific value enrichment, you can add the carbohydrate. That's the way we can able to enrich the food by adding that sufficient enrichers what we are going to have. Flour improvers. That is, during a bakery, I think everyone is going to be very fond of bakeries, that we are going to have the bread. What bread they are going to have, the bakery one and the company manufacturing one, if you can observe, the cutting will not be proper when you are going to see the normal bakeries what you are having. But when it is going to be seen in case of the manufacturing companies, they are going to have proper cutting of this one. This is because of staling agents. We are going to add anti-staling agent, that is called staling. they are not going to be get dividing properly. We are going to add anti-scaling agents, which is going to make the floor is not going to be sticky. That floor is not going to be get sticky, so that we can able to get equal half. That is, when you are going to cut it that one, that we can able to make a proper slices. That is what we are going to add anti-scaling agents to your floor, so that we can able to. And whatever you are having now, floors like wheat flour is originally brown in color, but now if you can see what are the brands you can able to available, that is Ashirwad, Annapurna, whatever it is going to be white in color. Why it is going to be white in color? So always we are going to make that floor to be attractive, so that we are going to make the flourishers, so that we can able to make the wheat flour is going to be get a white in color. So that is anti-bleaching agents we are going to make that color, whatever it is there, we are going to take it. And we are going to have food colors. One more you are having food colors. What food color? Food color is going to attract a person to eat that food. I think everyone is having these food colors. Even your non-veg, what we are going to use, always they are going to be added the saffron color, or we are going to have the orange red color, or a natural one we are going to have turmeric. They are all going to be comes under food color. Saffron and tamarind, sorry, not tamarind, we are turmeric. They are going to be the natural food colors we are going to have. They are going to be attracting the people to get impression on that food, so that we can able to eat that food properly. And also we are having artificial food colors also we are having. If you want to get red color or orange color, they are going to be added. Even green color also came nowadays. They are all going to be making the food is going to be more reachable for a person, and it is going to be making the more nutrient rich for the person. So this is about your food additives. What are the food additives we discussed? Food preservatives, antioxidants, artificial sweeteners, and food colors. These are the main things we discussed. We are supposed to remember the names what we discussed for answering questions which are related to your food concern. Understand? The next we are having the cleansing agents. What are the cleansing agents we are having? We are going to have the main cleansing agents are soaps and detergents. We are having soaps and detergents. What are soaps? What are detergents? What are soaps? What are detergents? Soaps are nothing but sodium or potassium salt of long chain fatty acids. Sodium or potassium salt of long chain fatty acids are called as soaps. And when we are going to take the detergents are nothing but they are going to be also the one of the alcohols, and they are corresponding with carboxylic acids. And we are going to discuss these soaps and detergents in the next class. So you are supposed to remember or by hearting the names and examples what we are given. That is compulsory for the drug concern, for the food additives concern. It's very much important. Okay, I hope everyone understand what we discussed today, and we can have the session. So when you are having the doubts, you can ask me during that interactive session. Thank you everyone.